Okay, next we're going to look at combining radicals. And combining radicals means that we are going to add or subtract them, just like combining like terms. And so in order to combine radicals through addition or subtraction, the radicands must be the same. So the value underneath the square root sign has to be the same. If the radicand values are the same, then you combine the coefficients and leave the radicand the same. Okay, so we're going to combine the coefficients and we're going to leave the radicand part the same. This is much like collecting like terms. Okay, so if we had 2x plus 7y minus 3x plus 2y, for example, what we would do is notice the like terms and then combine the coefficients of those like terms. Depending on whether it's addition or subtraction, we would follow the operation that's there. So our first example here says, which of the following are like radicals? So which one of them are like radicals? And so what we're going to look at is the radical part. And if the radical part is the same, then we know that they are all like radicals. If the radical parts are not the same, then we're going to see what happens from there. Okay, so you can see in the first example, we have 2 root 5, and then negative 4 root 5. And because all of the radicands are the same, then I know that all of these are like radicals. Okay, now the second example is a little bit different. I have 2 times the square root of 2, 3 times the square root of 8, and then the square root of 27. And now right now these look like they are not like radicals at all. Now I want you to think about this again and think about whether or not these are written in simplified form, because you can only really compare them if they are written in simplified form. And right now I notice that they're not in simplified form, so the first thing I will do is simplify any of the ones that are not in simplified form yet. The first one here is in simplified form since I can't break down the square root of 2 any further. But the second one here where I have the 3 times the square root of 8, I know I can simplify that further, so that's what I'm going to do. Okay, so I have 3 times the square root of 8. And I know I can simplify root 8 further. And that would be the square root of 4 times the square root of 2. That's the largest perfect square factor that goes into it. And the square root of 4 is equal to 2. And 2 times 3 is equal to 6. So this will give me 6 times the square root of 2. Now if you compare the first one to the second one in simplified form, you'll notice that these are actually like radicals. So don't let the fact that the number underneath the radical the fact that it doesn't look the same initially, don't let that fool you into thinking that maybe they are not like radicals. Okay? You have to have them in simplified form in order for you to be able to compare them. Let's take a look at the last one. So I know I can break this up into the square root of 9 times the square root of 3. And so this will give me 3 times the square root of 3. And now if you notice here, the radicand here is actually different. So the only ones that are like radicals are the first 2. Okay, so the first 2 are actually like radicals. Once you write them in simplified form, you can see that that they are very clearly like radicals. Okay, the radicands are the same. Okay, so now that we know how to look out for like radicals, the steps you would take to add or subtract radicals is to first express all radicals in their simplest form. So you want to make sure you simplify the radical part. And then collect like radicals just like you would collect like terms. So let's take a look at some examples. Okay, so some examples of adding and subtracting radicals. So the first example I have is 3 times the square root of 2 minus the square root of 2. And what you'll notice here is that there is an imaginary coefficient in front of the second radical, and that imaginary coefficient is just a 1. And because the radical parts are the same, because the radicands are the same, I'm going to subtract the coefficients. And so what I'll end up getting is 3 minus 1, which is 2. And then I'm going to keep the radical part the same. So I get 2 root 2. This is similar to if you had 3x minus x. Now if you had 3x minus x, you would simplify this and say, okay, well, because the terms are like terms, I can subtract 3 and negative 1 and I get 2x. It's the exact same idea here. So instead of having a variable, now we have a radical. Okay, second example, we're going to do something similar. And just like the warm-up, we're actually going to collect like radicals, so we're going to group them together and then we can combine the coefficients. So I have a radical part of root 3 And then there's another radical part of root 3. And then I have a radical part that's a root 5. Okay, so I'm just using different symbols to indicate what the like radicals are. And now if I simplify this or collect group like terms, I have 2 root 3 minus root 3 minus root 5 and plus 4 root 5. So remember to take the coefficient in front of each radical with you. Okay, and now I can collect them together. The like radical that I have here is root 3. If I combine the coefficients, I have 2 minus 1, which is just 1 root 3. So you can either write 1 root 3 or you can just write root 3. And then this part here I have negative root 5 plus 4 root 5. And so that's like negative 1 plus 4, which is positive 3. And then I'm going to keep the radical part the same. So plus 3 root 5. And be careful here. You can't combine these any further because the radicands are not the same. So that's as simplified as it would get. Okay, looking at part C and part D of the same example. We're still simplifying. So in this case, it looks like I can't actually combine the radicals in part C. But that's because they are not actually written in simplified form. So the first thing I need to do in this case is to rewrite this in simplified form. So instead of the square root of 75, I'm going to break this down into square root of 25 times the square root of 3 minus, I'm going to break down 48 as well. So 48 can be broken down into, I believe, 16 and 3. Now again, I'm going to emphasize this. You have to break it down into one perfect square factor and then another factor that comes with it. Okay? So you need to make sure the first factor that you choose is a perfect square. Okay? And now if I simplify this, I get 5 times the square root of 3 minus square root of 16 is 4 times the square root of 3. And now you'll notice that they are like radicals. They have the same radicand. And now I'm going to subtract the coefficients. And 5 times the square root of 3 minus 4 times the square root of 3. 5 minus 4 is 1, so I end up with square root of 3. And again, you can verify that your answer is correct by checking it on the calculator. And so if I actually look at the square root of 75 minus the square root of 48, I get about 1.73. And if I look at the square root of 3, I get about 1.73 as well. So I know my solution is correct. Okay, last one. This one's a little bit different. First of all, look inside the brackets. I have to follow the order of operations in this case since I have multiplication along with subtraction inside a set of brackets. And what you'll notice here is that I don't actually have like terms or like radicals. This has a radical part of root 3. This one actually doesn't have a radical part at all. So I have 5 root 3 minus 3. Can't do anything there. So what I'm going to do is notice that I have a 4 root 2 at the front. And so this is sort of like A times B minus C. I actually have to apply the distributive property and multiply the coefficient part with the first term in the brackets and then the coefficient part with the second term in the brackets. Okay? And so I'm going to do exactly that. I'm going to multiply 4 root 2 with 5 root 3 minus 4 root 2 and then multiplied with 3 as well. Okay? So the coefficient multiplied by the first term and then the coefficient multiplied by the last term as well. And now I'm going to multiply this just like I looked at earlier. When you are multiplying or looking at the product of two radicals, you combine the coefficient parts through multiplication and then you combine the radical part through multiplication. So 4 times 5 gives me 20. And then I can look at the radical part. 2 times 3 gives me 6. So I get 20 times the square root of 6. Minus, here I have 4 times the square root of 2 times 3. Again, I only have one radical part here. I can't combine it with anything. But the coefficient parts I can combine to get negative 4 times 3, which is 12. And then the square root of 2 stays the way it is. And if I look at these, if I can simplify the radical part so that the terms are like terms or like radicals, then I would combine them. But in this case, I can't simplify them. So this is as simplified as it gets. Okay, we have one more example. And in this case, it says, solve the following equation using the quadratic formula. So what I'm going to do is first rearrange this equation so that it is in ax squared plus bx plus c form. So it has to look like this first before I try to solve the equation. And so I'm going to move everything to the right-hand side just so that the coefficient of the x squared term is positive. And I get 0 equals positive 2x squared minus 8x and then plus 5. That 5 stays where it is so it doesn't change signs. And so I can try to factor this, but since the question specifically asks me to solve using the quadratic formula, I'm going to use a quadratic formula. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that'll give me x equals negative 8 is 8 plus or minus the square root of negative 8 squared minus 4 times 2 times 5 all over 2 times 2. So I'm just plugging in the numbers from the equation. And so that gives me x equals 8 plus or minus the square root of 64 minus 4 times 2 times 5. I'm going to do it all in one step. And I get the square root of 24. And now one thing to remember is that if you can simplify this, you should. And so that's what I'm going to do in this case. I notice that the radical part here is something I can simplify. And so I'll just do that on the side. The square root of 24 I can simplify into the square root of 4 times the square root of 6. And that gives me 2 times the square root of 6. And so I can actually rewrite this as x equals 8 plus or minus. So instead of writing the square root of 24, I can replace it with 2 times the square root of 6. All over 4. And what you'll notice is, if you look at the coefficient parts here, the 8, the 2, and the 4, remember I can only simplify a radical with another radical. I don't have any more radicals to simplify here, so I can look at the coefficient parts. I'll notice that the 8, the 2, and the 4 are all divisible by 2, so I'm going to reduce them all by 2. And so 8 divided by 2 is 4, plus or minus. 2 divided by 2 is just 1, so I'll just leave that as root 6. And 4 divided by 2 is 2. So what I did here is reduce the fraction by 2. And there's the solution in simplified radical form.